Hello everyone, welcome to EdiSure. So in the last class, we had discussed the concept of convergent sequence, divergent sequence, and oscillatory sequence. So we discussed three types of sequences. In today's class, we will give a formal definition of a convergent sequence and a divergent sequence. So we already noted that a sequence AN is said to converge to a limit L, okay, where L is a finite number, all right, finite real number, so it cannot be plus infinity or minus infinity. If given epsilon positive, there exists a natural number m such that mod an minus L is less than epsilon whenever n is greater than or equal to m. So this might look very complicated, but this is very easy. So what they're trying to say that the sequence an converges to L. If given epsilon positive, the distance between an and n is less than that number whenever n is greater than or equal to m. It means that for am plus 1, am plus 2, and so on, the distance between an minus L will be less than epsilon. For the remaining numbers, we can ignore that. Basically, a sequence converges to a particular number when the terms of the sequence less than epsilon distance from that limit for terms am plus 1, am plus 2, and so on. That means after a particular point, the terms of the sequence get closer and closer to the limit L. That is what we are trying to say. So it means that whenever we have n greater than or equal to m, the distance between the term of the sequence and the limit will be less than epsilon. So what they say is that you throw me an epsilon and I will give you a natural number m. That is what I'm trying to say. So for example, we had already done this thing in the last class. Limit n tending to infinity, 1 upon n is equal to 0. Okay. So I want to prove, suppose I want to prove that limit 1 tending to infinity, 1 upon n equals to 0. So what is an over here? 1 upon n. And what is L equals to 0? So choose epsilon equals to 1. So let epsilon equals to 1. Okay, let us see. So the distance between an minus 0, that is L, is less than 1. What does it mean? It means that the distance between 1 by n and 0 is less than 1. It means the absolute value of 1 by n is less than 1. It means 1 by n is less than 1 because absolute value of a positive number is a positive number. It means that take the reciprocal, n is greater than 1. So for all n greater than 1, this is going to hold. So given epsilon equals to 1, choose m equals to 2. So you can say that for all n greater than or equal to 2, distance between an minus 0 is less than 1. You can see that. You can see the sequence. The sequence is 1, then it is 1 by 2, then it is 1 by 3, then it is 1 by 4, and so on. Okay, so if you look at the first term, that is a1, so first term minus 0 is 1. So this is not less than 1. So what we have done, we have chosen the natural number to be 2. That means excluding the first term, all the terms are less than distance 1 from the limit 0. That is what we are trying to say. Try for another epsilon. So again, an is equal to 1 by n. Choose epsilon to be half. Okay. So let us see. So look at your terms. Now look at the terms like this. First term is 1. Second is 1 by 2. Third is 1 by 3. Fourth is 1 by 4. Fifth is 1 by 5, and so on. Okay. So distance between an minus 0 is again distance between 1 by n minus 0, which is nothing but 1 by n. Now I want this to be less than epsilon equals to half. So I want 1 by n less than half. So I want n greater than 2. So choose m equals to 3. So you can see that a3 is 1 by 3. So a3 minus 0, which is 1 by 3 minus 0, which is 1 by 3, which is less than epsilon. Similarly, a4 minus 0 is equal to 1 by 4 minus 0 is equal to 1 by 4, which is less than epsilon. But if you choose a1, it is 1 minus 0, which is 1, which is greater than 1 by 2. If you look at a2, that means half minus 0, which is half, which is greater than 1 by 2. So what do we mean by a convergence sequence? What we mean by a convergence sequence is that the distance between the terms of the sequence and the limit of the sequence will be less than epsilon after a particular number of terms. After finite number of terms, the terms of the sequence become become epsilon close to the limit. That is the definition of a convergence sequence. So this is known as epsilon m game. You give me an epsilon and I will return you an m. And if I'm able to do it for all epsilon, then my sequence is said to converge to that particular L. All right. Now, the next is the concept of a divergent sequence. Divergent sequence. Now, what do you mean by a divergent sequence? There are two types of divergent sequence. One divergent sequence is that when the limit of the sequence goes to plus infinity, and the another one is that when the limit of the sequence is minus infinity. So let us see. So what do you mean that the limit of the sequence is going towards plus infinity? It means that my terms are becoming larger and larger without bound. That means I will not be able to cap an with a particular number. An will always be greater than that number. For example, take a number g to be 1000. So there will be some an which will be greater than 1000. So whatever ceiling, upper ceiling I try to put on the sequence, there will be a term of the sequence which will be greater than that ceiling. That is what is meant by a sequence which is going towards plus infinity. It is becoming bigger and bigger. So how do we put it mathematically? It means given g positive, you take any positive number, there exists some m belonging to n. I will have a natural number such that an will be greater than or greater than g for all n greater than or equal to m. It means that, okay, suppose I want to challenge you that the limit of the sequence is not infinity, and I give you a number, suppose it is 10,000. So you will give me a term which is greater than 10,000. So for example, let us look at the sequence an equals to n. So it is 1, 2, 3, 4, and so on. So what is the claim? So claim is limit n tending to infinity, an is equal to plus infinity. Okay, so suppose somebody challenges me. It's that person says, no, 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 the limit of the sequence is 10 crores. So challenge, limit n tending to infinity, an is equal to 10 crores. So that is 10 into 10 raised to the power 7. All right. So I will say choose m is equal to 10 into 10 raised to the power 7 plus 1. So this AM will be equal to 10 into 10 raised to the power 7 plus 1. That is 10 crore 1. The element at this particular position at 10 crore 1th place will be 10 crore 1. That means my claim is false. The challenge is false. The limit cannot be 10 crores. So whatever big number you give me, I will be able to create a term of the sequence which will be greater than that number. And in fact, after that term, every number will be greater than that number. That is what we are trying to do it using the definition. So what we are saying? We are saying you give me a positive number, I will give you a natural number m such that the terms after that an, that means am plus 1, am plus 2, am plus 3, and so on, all those terms will be greater than g. That means barring a few finite terms. Now here the finite has come after 10 crore. So even after first 10 crore terms, if my terms start getting more than that particular number, the limit will be plus infinity. So the finite means any countable thing. Okay, so I should be able to restrict myself to some particular terms. Before that particular number, the term might be greater than g, but after that less than g, but after that the terms will start getting bigger than g. And that is the concept of a sequence diverging towards plus infinity. The next thing that we do is sequence diverging towards minus infinity. It means that the terms are getting smaller and smaller. It means that terms are getting smaller and smaller. So how will I claim that the limit is minus infinity? We will say given g negative, you take any g negative, okay, there exists a natural number m such that an will be less than g for all n greater than or equal to m. That means we are trying to say that am plus 1 will be less than g, am plus 2 will be less than g, am plus 3 will be less than g, and so on. So what I'm trying to say is that you give me a negative number and I will be able to find out a particular term after which all the term will be less than that negative number. Therefore, no matter how small a number you give me, I will be able to create infinite terms of the sequences which are going to be lesser than that negative number. That is what is meant by limit of a sequence tending towards minus infinity. So what we have done today, we have done the definition of a sequence converging to L. We have done definition of a sequence diverging to plus infinity. We have done definition of a sequence diverging to many minus infinity. Now, the mathematical definitions, they look very overwhelming because there are a lot of terms. But if you go by common sense, you can very well write those definitions. So let us write them once again. For L, given epsilon positive, there exists a natural number m such that an, distance between an and L, is less than epsilon for all n greater than or equal to m. Here, given G positive, there exists m belonging to n such that a n is greater than g for all n greater than or equal to m. And here, given g negative, there exists a natural number m such that a n is less than g for all n greater than or equal to m. So this is about the mathematical epsilon definition of a convergent sequence, of a sequence diverging to plus infinity, and of a sequence diverging to minus infinity. Thank you.